Hello, this is Mike Zellers. I am going to repeat the first part of the lecture today that was not recorded. And this will be posted as part one of week two's lecture. As we explored last time and we talked about last time, all the code that we're going to write in Java appears within classes. And a very simple example that we had last time, the Hello World example, only had one class and it did everything. It would be a very rare Java program that was like that for us. Normally we're going to have multiple classes. And what do I mean by class? I mean a class is a sort of template for real world entities. And there's three kinds of classes mainly. And let me bring up a Word document to describe the three classes that we'll have in our programs. In most programs. Again, this is a simplification. There's exceptions to this as well, but most of the classes that we create will be one of three things. There are our GUI classes, and by GUI I mean graphical user interface, or some kind of user interface. It's how the user interacts with our application. There then is going to be business classes. And I say business, but it doesn't even have to be a business. You could have, for example, if you're doing a game, you're not really doing a business, you're doing a game. And in which case, your business classes might be better described as problem domain classes. This is where really the logic of the application and the processing resides. Sort of the business rules, or business logic, or problem domain logic. For example, if I did a student object, there would be the rule to how to calculate a student's GPA would be contained within a business class for a student. Students are an important part of a college. They would be part of that problem domain. So if we're doing an application for a school or a college, students are one of the components that belong to that problem domain. Or another way to say it, belongs to that business. And therefore students and the logic surrounding students would be included within a business class or a problem domain class. And by logic, I mean things like, how do you calculate a student's GPA? How do you calculate a student's tuition? Does a student have enough credit hours to graduate? And so far. The last thing that we have is we have data access classes. And this usually links the rest of our application to the database. And we're not really going to consider them in this class, so we're going to forget these. So sometimes this is called a three-tier because, as you see, you have sort of three levels. User interface, business classes, or business logic, or problem domain logic, and data access. We're not worrying about the data access in this class, so I guess we're to one right off the bat. That leaves us with the GUI and the business classes. And we're going to focus most of our energy on the business classes, all right? However, we can't test the business class by itself without running it through a GUI or through some other kind of program. Well, we're not ready to write a GUI right now. So we're going to cover GUIs later in the semester, but still we need some code that's going to test our business classes. And that's where we're going to recreate a unit test class. Unit test class that you'll see in these examples are sort of a substitute for a GUI. It's going to use the business classes to hard code some problems and make sure that the outcome of those work the way that we expect. So I know hard coding is a bad word in a lot of programming environments. For the unit test class, that's acceptable. Because we're not going to keep the unit test class. The unit test class is there just for us to test and to make sure our business logic is correct. Later on in a full application, that's going to be replaced by some form of user interface. All right, what do I mean by a class? Classes have two kinds of code. in them. They have attributes and they have methods. Or another name for method is functions. So going back to the student class, some of the attributes are characteristics of the student. So for example, the student's first name, student's last name, student's birth date, student's major, list of completed classes, list of current classes. These are all characteristics of a student. In a class, we define the fact that our template for students, a student is likely to have, or is going to have, these attributes associated with them. All right? Even if some of these attributes are blank, like, for example, your first semester of classes, your list of computed classes is going to be empty. Okay. Or maybe you haven't declared your major yet, so your major will be empty or undefined. But again, when we define a class, we're defining a template for our students. A template is a description of an entity, and we contain all the characteristics of that. So first name, last name, birth date, major. We could probably think of others as well. Methods are sort of the logic and the calculation that goes into a student. Calculation. Now, an example of these would be calculate GPA. That would be an example of a method. There's logic in calculating the GPA. You look at all the lists of classes that the students completed, you look at their grade, you look at the credit hours, you get a weighted average of those to come up with the student's GPA. Or calculate tuition. In our case, we have two attributes that I haven't put up here. The number of credit hours and the residency code. Is the student in county, out of county, or out of state? Because if we look at LC's method of calculating tuition, which you do need to write code for in this upcoming assignment, you'll see that a student's tuition depends on how many credit hours they're taking and whether they're an in-county resident, out of county, and so on. And if you look at this, there's a little more involved than that. For credit hours 1 through 12, it's simply the rate of their residency code times the number of credit hours. For 13 through 18 credit hours, a student is charged for 13 credit hours. And then for 19 and above, you take that 13 through 18 amount and add each additional credit hour to it. So it's a little bit of a calculation, but it's something that can be fairly easily done. And I have a video in the week 3 module that describes how, that talks about doing this calculation. Okay. So class is a template for a particular entity. It has all the attributes and all the methods that that entity contains. Everything about the entity should be contained or encapsulated in that in that class. Now, last thing we're going to talk about for part 1 of this is the difference between a class and an object. A class represents all of an entity. An object represents one member of the entity. So, for example, there is a student class. That class is meant to represent all the classes that all the students that exist. a template for creating a student object. An object then is one member. So for example, in this course, there's 6 students. So there would be one student class that describes all the characteristics and all the methods that I'm interested in for those students. And then there would be an object, if I was doing a system, for each student. So there would be 6 different student objects if I was looking at all the students in this particular class that has enrollment of 6 students. All right, so class, think of it as being a template, and an object being one member of an entity. Class being a description of everything that members of that entity includes, attributes and methods, object being one member of that particular entity. I think this covers pretty much what I covered in the part of week 2 that was not recorded. So I'm going to finish this up, post it to Canvas, and by all means let me know if you have any questions. All right.